Now let us see about HSP, ESP and physical layer of IEEE 802.11. HSP hidden station problem is known to us where B and C are hidden from each other with respect to A in between. So here the CTS frame in CSMA-CA handshake can prevent the collision from a hidden station, where on receiving the RTS, when A as a destination sends clear to send signal, it is also being received by C, which is in its range, and it waits. It knows that A is under some transmission. But what about exposed station problem? So here this is range of B and this is range of A and this is range of C. C is exposed to transmission from A to B. So a station refrains from using a channel when it is in fact available. So use of handshaking in exposed station problem is going to be shown here. So when the request to send is being received, when A is sending request to send, where B as well as C both receive the signal, since A is also receiving, C is also receiving the signal from A. So B sends clear to send, and based on that, receiving that, A starts sending the data, and that data is also being received by C since it is in the range. So that is exposed station problem. And there can also be a situation where C, which is another station, does not uh, uh, may require to send some data, and that sends a request to send, and that request to send, which it wants to send from C to D for some transmission, it may also reach A. That may also cause collision while the data is being transmitted. So even though it gets the clear to send from D, it cannot send the data to uh, D. So such problem is called exposed station problem. So that's what is being explained here. Station A is transmitting to B. Station C has some data to send to D, which can be sent without interfering with the transmission from A to B. However, station C is exposed to transmission from A. It hears what A is sending and thus refrains from sending. In other words, C is too conservative and wastes the capacity of the channel, and it waits. In order to avoid such problems, it waits until the data transmission of A is over. Okay, so this C is very good C. In other words, C is too conservative. The handshaking messages RTS and CTS cannot help in this case. So station C hears the RTS from A and refrains from sending, even though the communication between C and D does not cause any collision in communication from A to C. Station C cannot know the station A's transmission, and it does not affect the zone between C and D. So this is exposed. Now let us see about the physical layer which lays below the MAC layer in case of 802.11. So there are 6 specifications. All implementations except the infrared operate in industrial, scientific and medical bands, that is ISM band, which defines 3 unlicensed bands in 3 ranges: 902 to 928 megahertz, 2.400 gigahertz to 4.835 gigahertz, and 5.725 gigahertz to 5.850 gigahertz of frequency. So this is being used as the band, and based on that band division, there are several IEEE standards being defined, like 802.11, 802.11a, 11b, 11g, and 11n, based on various techniques being used, based on the modulation techniques which are also being used, and the rate remains like this. Let us see them